All right, today we're going to finish up chapter 9, talking about how to solve systems of equations. So it's similar to what we did yesterday in the sense that you are solving for an answer. The difference is we won't be graphing today. All right, so the first thing we want to look at is if it just asks you to determine if each ordered pair is a solution to the system of equations. So it gives you these two equations here. Y is equal to 7x minus 4, negative 14x plus 2y is equal to negative 8. And it wants to know, is this first ordered pair a solution? Is the second one? So for each one, you need to determine yes or no if it's a solution. All right, if it is a solution to one of them, it has to be a solution to the other. So how you do this is you plug in the values for x and y into each equation. All right, so let's just start with the first one. I'm going to start, so I'm going to plug in negative 2 for x, positive 5 for y. So y is 5. 7 times x, the x value, remember, from the ordered pair is negative 2 minus 4. Okay, so 7 times negative 2 is negative 14. Negative 14 minus 4 would give you negative 18. All right, so we know 5 is not equal to negative 18, so it's not even a solution to the first one. So we know it doesn't even matter if we plug it into the other one, because if it's not a solution to both, then it does not work. Okay, so we're going to go ahead and mark that one as a no. All right, then we're going to move on to the next ordered pair, negative 1 and negative 11. So again, we're going to plug in negative 11 for y, and then negative 1 for x. So we get negative 11 is equal to 7 times negative 1 would give you negative 7 minus 4. So negative 11 is equal to negative 11. So it worked in the first equation. Now you need to check that same ordered pair in the second equation. All right? So negative 14 times x, the x value we're using is negative 1, plus 2 times y, our y value is negative 11, should be equal to negative 8. All right? Negative 14 times negative 1 will give you positive 14. And then 2 times negative 11 is negative 22. If you take 14 and subtract 22, you do get negative 8. All right, so that ordered pair worked for both. So yes, it is a solution. All right, we're going to try the ordered pair 3, 17. Again, we're going to plug that into the first equation. Y equals 7x minus 4. So our y value here is 17. Our x value is 3. All right, 7 times 3 is equal to 21. And 21 minus 4 is 17, so that works. Now we need to check that same ordered pair in the second equation. So negative 14 times x, that x value is 3, plus 2 times y, which is 17, should be equal to negative 8. All right, so if we take 14 or negative 14 times 3, you should get negative 42. 17 times 2 is going to give you positive 34. Okay, and then negative 42 plus 34 is going to give you negative 8. So that checks also, so they work for both. So yes, this is a solution as well. All right, and then the last one, 0, 4. Again, we're going to plug in 4 for y. So always start with that first equation, and then plug in 0 for x. 7 times 0 is 0, and then 0 minus 4 would give you negative 4, so this does not work, so we know that's going to be a no. All right, so it's a lot of work just to write out, but you just need to go through and check ordered pairs. If an ordered pair doesn't work for the first equation, don't bother checking in the second. If it does work for the first, make sure you check them in both. They do have to work for both equations. Okay, now we'll kind of really get into how to solve systems of equations. So notice here the directions say solve for x, so it just wants the value for x. Now, if you look right here, one equation says y equals x minus 11, The other says y is equal to 15. So if we know y is equal to 15 here, you can replace y in the other equation with 15. All right? So that's what we're going to do. We're going to rewrite that first equation, but instead of y, we're going to put what y is equal to, which is 15. So 15 is equal to x minus 11. All right, now we can solve for x. All you need to do to get x by itself is opposite operations. So we add 11 to both sides. Negative 11 plus 11 will cancel. That would leave you with x is equal to 26. Okay, this one is going to be the same idea. It says solve each system of equation. The difference here is it doesn't give you a specific variable. That means you need to solve for both x and for y. All right, so notice in both equations y is by itself. So here y is equal to 9x. In the second equation y is equal to 2x plus 49. So if both of these are equal to y, that means you can set those two things equal to each other. All right, so that's what we're going to do. We're going to take the first part, 9x, and set it equal to the second part, 2x plus 49. Right? Again, we can do that because both of them are equal to y, which means they are equal to each other. Okay, then from here we can solve for x. So we want to move anything that has x to the same side. Here it would make sense to move it all to the left side because all that's over here is x anyway. All right? So we're going to subtract 2x from both sides. Remember, if you want to move both a variable and a number that are together, you have to use addition or subtraction. So 9x minus 2x is going to give you 7x equal to whatever you have left, in this case positive 49. Then all you need to do is divide both sides by 7 to get x by itself, and you would get x is equal to positive 7. Now, on this, you have to have both an x and a y value, right? So it's your choice. Now that you know x is equal to 7, you can plug that in for x in the bottom equation or the top equation. You can choose whichever one that you would like to, okay? I'm going to choose the top equation here. Y is equal to 9x. I'm going to substitute. I know x is equal to 7, so I'm going to replace x with 7. All right, and then all you have to do are multiply those two things together. 9 times 7 we know is equal to 63. All right, so here we have an x and a y value. Now, everybody always asks, can you plug it into either? Yes, I did explain that before, right? If we plugged it into the other one, 2 times 7 would give you 14. 14 plus 49 is also equal to 63. So you do get the same answer either way. Sometimes you're just going to find which one you would rather plug into. All right, this is the exact same type of problem here. Both are equal to y, so again, that means you can set x plus 16 equal to 5x minus 12. So let's do that here. X plus 16, and we're going to set it equal to 5x minus 12. All right, same thing, we're solving for x, so I want everything that has x on the same side. I always like to move the value of x with the smaller number in front of it, so that would be here, minus 1x. Remember, if we don't see a number, we know it's 1. All right, so x minus x cancels. On the left side, I would be left with 16. On the right side, 5x minus 1x would give you 4x, and then we need to bring down that negative 12. Okay, so we've put everything with a variable on one side. That means everything that does not have a variable needs to go to the other side. So we need to get that negative 12, we need to get rid of that and get it to the other side. So use opposite operations, add 12 to both sides. On the right side it cancels, leaves you with just 4x. On the left side you add those two together, 16 plus 12 is going to give you 28. Alright, your last step here is just to separate 4 and x to get x by itself. So we divide both sides by 4 and we get x is equal to 7. Alright, same thing as last time. Now you just need to go choose one of those equations to plug into. It looks like the top equation is going to be the easiest one, y equals x plus 16. So we replace x with the value we got, which was 7. And then all you have to do is add those two numbers together. 7 plus 16 is going to give you a total of 23. All right. The next thing it's going to ask you to do is to use substitution to solve the system of equations. So in a sense, it's a similar idea, right? Notice the bottom equation is equal to x. So if x is equal to 3y plus 7, that means you can take this 3y plus 7 and replace x with that in the other equation. It's similar to what we did at that first problem over here, right? When y was equal to 15 and we replaced y in the first equation. So it's going to be that same idea. We're going to rewrite that top equation, but instead of x, in parentheses, we're going to write what x is equal to, right? The part that I've circled. So we replace x with what it's equal to, which is 3y plus 7. And then everything else from that top equation stays the same. All right? Now before we solve, we need to get rid of these parentheses. We do that by distributing. So if I distribute that -5 through, -5 times 3y would give you -15y. -5 times 7 is going to give you -35. Okay? Now, here's where you need to make sure you don't get confused. Notice both these variables are already on the same side. So we don't use opposite operations, we just do what it's asking us to do, right? So -15y plus 2y, if I combine those like terms together, would give me -13y. Bring down that -35, set it equal to -22. Okay. Now that we've combined like terms, we can get the variable by itself. So notice on the right side I have just a constant or a number. So I want to move all other constants over there. That would be 35. So I add 35 to both sides. When I do that, -35 plus 35 on the left is going to cancel out, leaves me with just -13y. Alright, when I add -22 and +35 on the left side, signs are different, so you can subtract and take. That would give you +13. Alright, and then my last step to get y by itself is just divide both sides by -13. When I do that, I'm going to get y is equal to -1. Alright, so again, I'm close to being to my answer. I got the value for y, now I just need a value for x. Just like earlier, it does not matter which one you choose to plug that into, but notice the bottom equation has x by itself, so that's going to be your easiest one to substitute back in for. Alright, so x is equal to 3 times y. I got -1 for y, so I'll substitute that in, plus 7. 3 times -1 is going to give you -3. Add 7 to that. Then all you have to do to get your value for x is take -3 plus 7, which is going to give you +4. Okay, I know it's rather lengthy, so we are going to do one more example just to make sure we're clear on using substitution. Alright, so when you're using substitution, always look for a variable that's by itself. So notice the top equation has y by itself. That means everything y is equal to, you want to substitute for y in the second equation. So we're going to start by copying down that second equation. Nothing changes about 5x. Then we're going to do 2 times y. Well, what am I replacing y with? I'm replacing y with 2x plus 7. That's where I'm substituting. And then everything else about this stays the same. Alright, before I can combine any like terms, I have to get rid of those parentheses. We do that using distributive property. So 5x is going to come straight down. 2 times 2x is going to give me 4x, and then 2 times 7 would give you 14. All right. Your next step is to combine like terms. They're already on the same side, so you don't use opposite operations. That's only when you're moving across the equal sign. So 5x plus 4x is going to give you 9x plus 14 is equal to negative 13. Now from here, notice there's nothing else we can combine like terms, so we need to get the variable by itself. So we move all constants now to the right side. So the opposite of adding 14 would be to subtract 14 from both sides. When you do that, positive 14 minus 14 would give you 0, so that does cancel. Leaves you with 9x equal to negative 27. Alright, we all know our last step to separate 9 and x is use division. So we divide both sides by 9. We get x is equal to negative 27 divided by 9 is going to give you negative 3. Alright, so same thing, we're close to being finished. Now we know that x is equal to negative 3, so we just need to substitute that back into one of these equations. We're solving for y, so again, I would plug it in here, the one that's already equal to y. So y is equal to 2 times x, the value for x we got was negative 3, and then we're going to add 7 to that. Alright, so 2 times negative 3 is going to give you negative 6, and then negative 6 plus 7 is going to give a y value of positive 1. Alright, so just make sure you're careful when you go through these. Take your time. Again, you don't have a lot of questions to do on this, so please don't rush through it. Make sure you're very careful about using substitution.